questions, then we go to our last speaker. This is Christian Williams. Hi, Christian. And he will talk about colors, strings, and beads, a way to develop a visual language to talk about mathematics.
Thanks. Let me just share the iPad. Okay. Hi. My name is Christian Williams. I'm a fifth-year math PhD at UC Riverside. I'm studying category theory with John Baez. And today I wanted to share with you colors, strings, and beads, visual language for math education. And yeah, thanks a lot for having me. And this is a really cool conference. One quick preface. So the language that I'm going to talk about is a formal language in category theory. But what I'm presenting is an educational idea or a vision for its potential in math education. Yeah, I'd just like to preface that it's pretty new and undeveloped and kind of rough. So it would be great if this could be informal, and just feel free to jump in with any questions or thoughts. Yeah, so rather than talk about the language, I think it's just good to jump into it because it's very simple. There are colors or colored regions, colored areas. You don't have to draw it perfectly. Strings which connect colors. So let's say you have a purple string that connects yellow to let's say blue. Whoops. So strings connect colors, and beads connect strings. So if you have one string, let's draw this well. Let's say you have the purple string connecting yellow to blue. I keep doing it. You have a purple string connecting yellow to blue. And let's say you also have a, let's say a green string. Oh, sorry. Green string from yellow to blue. You can have a bead between them connecting from purple to green. And that's it. These are the basic elements of this language. It's extremely simple, but the first important thing to note about this language is that it is two-dimensional. So most of the languages that we use in math and science are compressed into one dimension. And a lot of the time we lose intuition through that compression. And so this two dimensions allows us to express concepts more easily. Okay, but what's the basic idea? What is this actually expressing? So the reason why this turns out to be, so these are the basic elements. I'm about to talk about how you actually use the language and what you can do. But just a general idea of why is such a language able to express concepts. The general idea is that colors are like types of stuff, types of things in the world, like animals, plants, people, foods, furniture, whatever. Strings are relations or connections or judgments between types. So I'll just say relations between types. So this string could be the relation between animals and foods, and the relation could be eats. And you can put this in front of a kid and you draw some animals on the left side, some foods on the right, and they can draw connections when an animal eats a food. So we have types when we just recognize types of stuff in the world, relations between them. And then beads are inferences, the actual process of reasoning from one judgment to another. So here this says, if an animal eats a food, then the animal, let's say this one can be like, can digest the food or something. Just some relation that would follow from being able to eat the food. So the idea is that this is a colorful, intuitive language that reflects how we actually think. And the idea is that I believe that giving this language to children early in life and using it as a general language for math could have a significant impact. Is there a question? Oh, okay. So that's the general idea. Any questions so far? Cool. Okay, so what can you actually do in the language? So there's just a few basic rules. Let's say you have the first question is, how do you make new strings? So if you have a string from red to green and a string from green to blue, what's the natural thing you want to do in this situation? If you set this in front of a kid, what's the natural thing they want to do? Yeah, we're gonna stick them together. Yeah. So to us, we would know this as composing relations or composing functions. And we've thought about this a lot, but I think even to a child, this is very intuitive. And I think that the idea that everything has a type, and that as you go further into math, you realize that types and logic contain a lot of the weight and content of what we're thinking about. That is really not appreciated and reflected in most of math education. They don't care about the formal side. And I think that colors are a very simple way to introduce children to the concept of types very early, because they would know that you can compose these two strings because they match on the color. Yeah, so one thing you can do is that strings compose. And the other way that you can make strings that is a little more mysterious for the kid at first, but then they start working with it and they see how it works, is that every color has an identity string. So to us, we are familiar with algebraic structures having identities or units, but this would be very random and strange to a kid, and that's okay, because you start to see, oh, well, that lets you do cool things with beads. So you can draw this. you can just explain to a kid, oh, every color has a ghost string. You can draw it if you want. You don't have to. It's there whenever you want it to be. Composing with it doesn't do anything, but it's cool because you could have a bead from the ghost string to like real strings and vice versa. Yeah. Any questions? So these are what you can do with strings. Now the interesting part is how can we compose beads to make new beads? So notice here, colors just define some space that we're going to draw on. Strings divide it and they introduce a dimension. Strings connect colors from left to right. The direction was arbitrary, but once you pick a direction, it matters. Beads connect strings, and so now you have fully two dimensions that beads are connecting from top to bottom. And so with strings, because they were one-dimensional, there was only one way to compose them. All you could do was just stick together along the middle. But with beads, I shouldn't have drawn over that one. It's okay. So now I propose that there are two ways to compose beads. So let's say you have a bead. Sorry, I'm gonna forget about the colors for a minute. Let's say you have a bead from yellow to purple. What is one way that we could compose this with another bead? Let's say we have this bead here, and it represents the inference, like you have a yellow thing and a purple thing. If they're blue related, then they're green related. This bead represents that inference. And I can draw it here. If they are, I'm stalling for time. Somebody propose how we could compose this with another bead. If this, then this. I actually like that it's hard to do this fast because it gives people time to mull over. Okay, so one way that we could compose this with another bead is in sequence. So we could connect along the green string. And this would be like composing implications. If you're related in the blue way, then you're related in the green way, then you're related in some other way. So you can have some other bead here. Orange here. You can compose beads in sequence here. So this is one way that we use inferences in everyday life. But there's another way. We have two ways to reason or to compose reasoning. And that's really important. Does anybody have a guess? What's the other way? There's two dimensions here. We just used one dimension, right? We were composing vertically. And that was like, if this, then that, then that. So what would the other option be? I think some people know, but they aren't saying, and that's okay. So we could also go the other direction. We could go horizontally, right? So we could have another bead over here. from purple to something else, to another type of thing. Let's say, one thing you quickly notice is that you need tons of colors. And so after a while, you just use black for the strings and like use context to tell what's what. But anyway, yeah, we can also compose in parallel. So this is just two distinct inferences side by side. This is something that we use in everyday life. It's like you just have independent facts, reasoning. And then if you want later, you could like bring them together. Yeah, so we can compose both in sequence and in parallel. And this reflects the two ways that reasoning composes and parallel. And that's it. This is the whole language. It's extremely simple. It's just a two-dimensional language for composing concepts, basically. It's just a simple language for types and the way that they're related and how to infer between relations. And so one of the really powerful things about this language is that it is general and abstract. This is really a language for two categories, two-dimensional categories. And so there are many different universes that this could represent. And I think that's really useful to provide students with a unified language that they could use like throughout many years of math. But the simplest one that you would want to start with for children is that, yeah, the colors are sets, the strings are relations, and the beads are implications. And I actually think that you can teach this to, honestly, like kindergarten or first grade. Like, I think that they can draw relations between animals and foods, like maybe even easier than like numbers. I think numbers are kind of a weird abstraction to start with. Yeah, so there's a lot that I could start to show, but of course there's only a few minutes. So I'm just curious what y'all think in general about this. Yeah, so basically I believe that math should be empowering. The real purpose of math should be to provide people a language to express ideas. And right now it's doing the exact opposite of all of that. It's disempowering, it's confusing people, it's giving them anxiety about their own reasoning, and it's all just wrong and backwards. And yeah, I believe that giving people an intuitive language to express concepts is really important. So I'm interested in developing this as an educational program, and I am looking for guinea pigs that are interested in trying it out, but also I don't have connections to people in education. So if you know anyone or have thoughts of like ways that I could actually try it out with, like, you know, middle school or whatever, that would be really helpful too. But yeah.
Yeah, an idea that comes to my mind, that might be a good thing to try out in after-school programs.
Yeah.
Because people are less scared.
Yeah, definitely.
So if we could reach out to Star Education or some other after-school company, they might want to try this out, you as a guest teacher, or give you some kids, or connect you to other teachers who want to try it.
Yeah, did you say Star?
Yeah, One Star Education is one of the bigger company, at least here in Los Angeles.
Okay.
Star, like the stars in the sky.
Yeah.
just in capital letters.
Okay, yeah, I'll check that out.
And there are also many others post school
Great.
companies.
I'd also check at your institution and see if you have any like outreach where students come on campus and they're looking for things. A lot of times they're trying to engage students in STEM or in math, and it goes at all different ages. Math teacher circles also hit on like sort of middle school kids. So if you're looking at that age, right, you could try to catch up with one of them, and you could pose this as an activity. It's like a low floor, high ceiling thing.
Yeah, definitely.
So,
yeah, that would be great. Yeah, well, thanks a lot. And yeah, if anyone's wants to try it out, just yeah, I've been showing it to people outside of math too, and they really like it. But feel free to.
The other big thing that comes to mind, this is probably too big to start, but the Julia Robertson Math Festival that happens all of the time, where they really engage people throughout the community at all ages, and they basically give things like this for students to play around with. So
cool.
They might give you an idea of how to develop something.
Yeah, that would be great. All right, well, thanks a lot.
Thank you.